He's got the whole world on his mind. Our next presenter, Piers Corbyn, is we've heard about him. His work has been referenced throughout the weekend, and we've heard from Piers a number of times. Now it's going to be his chance to hold the light, hold the spotlight, and hold his ideas up before us. He has his first class degree in physics from Imperial College, his MSc in astrophysics from Queen Mary College, and he operates the Weather Action, I've got it right here now, I had it memorized, Weather Action long-range forecasting site on the web, weatheraction.com. There's a free and a subscription-based way to sign on there, and as we heard from Bob Weber's presentation earlier this weekend, Piers is connecting, bringing the sun's behaviors back into the world of our weather forecasting. So welcome to the stage, Piers Corbyn.
Well, thank you very much, David. In the intro to me in the documentation, it says that I was recording the weather from when I was 5 years old. Well, actually, I have to say that's an exaggeration. But when I was 8 years old, I did make what I thought was going to be a dew pond, and it didn't work. But a more exciting thing, which is not in that thing, that report, is that I had tea with the Queen when I was president of Imperial College Student Union. And I thought that would excite you a lot more than anything else. Or if I was Barack Obama, I'd put it the other way and said, well, the Queen had tea with me. Now I realise... Okay, so the Republicans applauded then and the Democrats didn't. Now, I know I've lost all Democrat support now, but I'll also mention that my brother is a left-wing Labour MP, so now I've lost all Republican support as well. But of course, I say that because we are in a situation where, you know, symbols spin, what people believe, what flag they hold is taken as their whole meaning. Whereas, you know, the only thing that counts is evidence, evidence-based science. So whatever my associations with Her Britannic Majesty or not, for example, you know, what I say and the evidence for it is the only thing that counts. Okay. We are in very challenging times, and I think it's fair to say that we're going to make mistakes, so we have to be careful. Now, where do the leading institutions stand? The leading science institutions, do they put science first? Anyone want to offer a yes or no? No. No, yeah, I agree with that. Good, so we're getting somewhere. Now, but I want very specifically the issue of John Harrison, the inventor of the clocks which made measurement of longitude possible, and his arguments for the Royal Society. It took 30 years for his work to be recognised because the Royal Society insisted that Newton would have thought that you should use the moon or something, right? And therefore they wouldn't give him his prize. And it was only when the Admiralty intervened and said, look, people are dying at sea every day because we're not using intelligent equipment. Do it. And, you know, he eventually got his prize 30 years later. But the Royal Society is still, now, it's probably worse than then. Because then it was kind of independent and had its own mind, which was pretty freaky. But now it is basically an extension of government. And, you know, it's just ridiculous. The stuff they put out as science is non-science. I go to meetings and explain that carefully, and it's a discussion meeting, and you look in the minutes afterwards, what? There's nothing there. Was I at that meeting? Apparently not. So, there we go. Anyway, does science advance? Well, yes, or how does it advance? But it doesn't advance by consensus. Consensus has never advanced science, and I've got to stop rambling and move on. But Niels Bohr said, when he put forward his theory of the atom, which denied electromagnetism at that point of time, said it may be crazy, but is it crazy enough? And I think, you know, I recognise everything Dave Talbot does. I mean, is it crazy enough? And the answer is probably not. There may be mistakes in it, but, you know, we've got to be bold. We're going to have to clear the way for very big changes in science. We can't rely on these institutions. We're going to have to think of new institutions. That's a tall order, but we're not going to change the world by tinkering around with nonsense. First of all, we're going to go through assumptions of classical meteorology. We're going to talk about our forecasts and why they can be done and give some examples. We're going to have a few comments and jokes about carbon dioxide, and then we're going to talk about what's coming in the future. Okay. Now, the main problem with standard meteorology is its belief system is weather drives the weather. Okay? Well, that's kind of true. What happened yesterday affects what happens today, but they forget what's driving from above. In fact, they don't believe anything drives from above. So, these signals we see in the weather, 22-year cycle, 60-year cycle, 155-day cycle, which is the same as the solar flare signal on the sun, all these things are in real weather data. Standard meteorology can't explain any of them. Okay, now how little CO2 is there? Anyone know? Oh, no, you all know, so I won't ask you. Okay, we'll move on. Next one. First evidence of possibly magnetic important links. Now, this is Ice Age stuff, and I realise that, you know, the timing may be wrong, but significant things here is if we got a magnetic connection between the sun and the Earth, so here's the Earth, here's the sun, magnetic connection, so if the sun's magnetic field comes up and joins the Earth like that, it's good connections, and down here it's bad connections, and that is an odd cycle is good connections, even cycles are bad connections, for example. Then, you know, and the tilt of the Earth towards the sun would affect magnetic connectivity and so forth, and the precession of the spin axis relative to the sun, you know, either near pointing towards the sun or away from the sun, would affect connectivity. The tilt is a 43,000-year signal, the 26,000 years precession, and if you do a little few sums, then we have that 3 times 43 is 129, 5 times 26 is 130, so they're similar, so you might get spaces of 130,000 years between ice ages, and indeed, or between the warm periods between ice ages, and indeed we have. The last big one was 130,000 years ago. So, magic. Also, some of these things, these two are separated by 86,000 years, which is 2 times 43, and this other one down there, these two, the lower graph is temperature, by the way, and the upper graph is CO2, and the CO2 follows temperature. That's about 43,000 years. So there's some type of, you know, magnetic connection there. Of course, I see we've got a problem here if all these timings are wrong, but then maybe this tilt thing is wrong anyway. So, yeah, you know, but there's evidence in this of magnetic connection. Now, next one. Who remembers Fourier analysis? Wow, that's fantastic. Usually is nobody. Okay. When I speak to farmers, they say, what? Then I say it's all about things going up and down, and then they understand. Okay. The main signal from the sun in terms of solar activity, radiation, you know, TSI, total solar radiance, solar activity being geomagnetic activity as well, is 11 years. But the main signal in world temperatures is 22 years, which is the magnetic effect. Now, so you've got to be very careful straight away, assuming that solar activity is controlling temperature. No, it's not as such. Neither is cosmic rays, which are modulated by solar activity. Neither is TSI. They are positively correlated in odd sunspot cycles, and it's noisy and even ones. So overall, smooth it out, it's correlated, but in detail it's not. So, you know, the theory of cosmic ray modulation of the weather is immediately disproved by this existence of the 22, not the 11 as the main signal. Okay, another very important thing is the 60-year modulation, which is beats between the rotation of the nodes of the orbit of the moon, i.e. where it crosses the ecliptic, and the 22-year magnetic cycle. And this is an American graph of American data, because if it doesn't happen in America, it doesn't happen anywhere. And it's pretty convincing. And Joe Dalio put that stuff together for me, and you know he's a famous American meteorologist. Right, now, what about what's going on then in terms of the sun every 22 years? Well, in electricity, and I did this after a conversation with Dave on the phone. You see, there's a current sheet coming from the equator, basically. It's a great wavy thing, but it comes out from the sun, and particles move outwards, right? So in the odd cycle, you've got to have positive current moving in, so it means the particles coming out are electrons in the odd cycle. In the even cycle, it's going to be protons as the net charge coming out. So that could be important. They're different, okay? And which is not surprising. And then we have different responses on the Earth. Okay, and what we have on the Earth is, of course, quite a complicated thing, and you've seen this diagram before. This is the current sheet, which is very wavy, and it goes round and round, and in fact the direction of the field changes, might be once a week even, as the magnetic sectors change. And I just drew some of this. I didn't draw this, I lifted this off something, but just to show the complexity of all these currents happening way above the atmosphere. But these are fundamental to what happens to the jet stream and the circulation of the Earth. And the interesting one here is the magnetic tail, which is connected to the way back there, which of course the moon hits every full moon, or well, depending how close it is, how close to an eclipse. Okay, now very interesting stuff here about angular momentum and rotation. Now, this is magic, you might say. It's a fact that the magnetic, the spin of the sun relative to the Earth, or the magnetic sun, it looks more or less rigid in magnetic terms, and its period is, well, 27.21 days. Now, the lunar nodal period, that is the period as you watch the moon as it crosses the ecliptic and comes round and goes round again, is 27.212 days. They're the same. Now, there's one other planet moon system in the solar system where something like that happens. Pluto and Charon. The ratio there is 4.0. Now, to me, that means there's some sort of feedback going on involving the solar wind, and rotation and angular momentum, and it works for these two, we think, because they're relatively similar masses. It's a very big moon with the Earth, and with Charon and Pluto they're even more comparable. So some sort of feedback. It doesn't happen with any other moons in the solar system. This astounding unique whole number ratio. Now, to carry on about angular momentum, and we could go on for ages, but a lot of people think, oh, meteorology, yeah, Coriolis force, yeah, sure. Things spin round because when... Can I get in front of this? Let's put America on the front. There we are. Right. Here we have America on the front. Okay, people think, oh, yeah, spin of the Earth is 25,000 miles in a day. That's 1,000 miles an hour here. 60 degrees up, it's 500 miles. So... an hour. So if air from here meets air from there, they've got a 500 mile an hour speed difference, and that can give rotation. But of course, well, hang on, low pressure systems don't have air moving that far. And anyway, if that's going to make a speed difference, what happens to all the air in between? It's got to disappear and the angular momentum stay, and the velocity. So it doesn't work. So when you talk to people involved in storms, they say, oh, yeah. No. What happens in the upper atmosphere, we're going to have horizontal rotation, and that gets flipped over somehow, and you get this spinning. Well, which is fair enough. It works to an extent, but they really struggle to get high speeds out of it. Really struggle. So there's something else is needed, and you need something involving electricity, magnetism, rotation, and so on to get the fantastic rotations we do see in real hurricanes, real tornadoes, and so forth. And of course, we can predict a lot of these through our system. Okay. Now, what is really going on is, of course, these are temperatures, Bronze Age, medieval optimum, and further back there we've got the Bronze Age. We've got these little ice ages and the Dickens winters. This is the Dalton minimum, which is very interesting. And corresponding to all of these cold periods, there were low periods of solar activity. Okay? Well, that's a pretty good guess about something involving influence, especially because of the magnetic arguments I've just put. Okay. So the key question is, what causes weather extremes and climate change? And the answer to that is, and all the standard meteorologists say, yes, jet stream, the position of the jet stream is fundamental. And I was at a meeting in the Royal Society recently where the other side stood up and said, we're doing this loads of fantastic work on CO2, but unfortunately we put lots of CO2 in the models and the jet stream just does what it always did. It doesn't wave around wildly like it is now. And I stood up and said, well, I'm not surprised. We predicted it would wave around wildly now because it's solar activity. And then they sort of looked a bit bemused and said, well, we could consider some of your inputs into our models. Perhaps, Mr. Corbyn. But then I thought, that's insane. You can't put sensible stuff into a model of madness. So I didn't take him up. Okay. So, our revolution is we predict changes in the jet stream due to a solar-driven thing, which are driven by those currents above, the electrojet, lots of stuff going on. And furthermore, we can say that sometimes the jet stream will wave around wildly, like it did, and we predicted this, and give you these great big incursions of cold air, for example, that happen there, and so on. And during periods of low solar activity, the jet stream is generally longer, and as therefore it's got more wriggle room, which politicians like, of course, more wriggle room, it can go up and down more, but also we think the solar wind and changes in it actually make it go up and down more. So you've got these wild changes, big extremes, largely predictable. So, and our message is, long-range forecasting can be done, it is being done, and we're the gaffers. We're not always right, so 20% of the time we could be wrong, even seriously wrong, but our success rate has improved, and it's peer-reviewed, independently proven, by the way, not just me. And we can do one-off extremes. And a very important development we have now is, we call these R5 and R4 periods. There are measures of solar impact on weather systems. And we're in an R5 now, by the way, and there's been a lot more rain and hail around in Britain and the USA, as we predicted. And furthermore, we've had a bit of a rush of earthquakes, which is a kind of side thing I'm doing, purely as trials, but it has been working quite well. Right, now the key to all of this then, the basic idea is, we're going to have world temperatures, or indeed any weather parameter, is going to be a result of solar activity, which is an 11-year cycle, modulated by magnetic links, which together, of course, that gives primarily a 22-year cycle, but with some wobbles in it, and lunar modulation, which is about this rotation of the plane of the moon's orbit, which on the monthly basis is 27.2 days, but it's to do with the 18.6-year rotation. Now, obviously, we haven't got a computer big enough to solve any of this, even given the arguments about what equations to apply anyway. So what we've done is we've got these magic, we can use the word here, equations where I predict what I call weather action indicators, which are essentially descriptions of solar activity, magnetic links, lunar modulation, the total Sun-Earth magnetic linkage state, okay? And there's, a few parameters, and there we have. We've got W1, W2, W3, and so on. So we say, okay, these are varying. What are they going to be at Christmas? And when were they last like that in the past around Christmas? And then we say, well, okay, yeah. This world is simple enough, maybe, to have one input gives roughly one output. Therefore, input then, And output then of the weather then will equal the weather in the future. And we use weather maps in the past as models for the future. Okay? And we modify them a bit because, oh, hang on, there's an R5, so woof, big storms and so on. But we can look in the past, we can shunt around a bit and find where there was obviously a lot of activity going on. And we can even make estimates of what the sun was doing, but you've got to be careful on that one. We've also done predictions of sudden warmings of the stratosphere, known in the trade as sudden stratospheric warmings. And these were known about to astrophysicists years ago in the 60s, and they noticed that the jet stream actually started waving more a week or so after these things. But they didn't tell the meteorologists, and the meteorologists wouldn't have been interested anyway. It's only recently this has come to light, and we've made successful predictions of them. And as a result, this might even be on the next slide. Let's have a look. See, when they wave around a lot in the winter, these are winter phenomena, the important ones anyway, you get big waves in the jet stream, and then you might get shuntings out of cold air and snow. And here we are. I made a snowman this is February or January 2013. And my son, since we've been mentioning sons a lot, took a photo of me holding a newspaper, which you can't read, which has got snow on it. And Joe Bastardi said, Piers Corbyn has no peer in the stratosphere. Okay. He's not a poet and he doesn't know it. Oh, okay. But I thought it was really cool having Joe Bastardi singing my praises. That's magic. Okay. Right. Now, if there's any truth in this stuff, we think, well, okay, 6 times 22 is 132, and 7 times 19, that's about 18.6, is 133. So, okay. Every 132 years, you might get things very similar. Now, it's not detail, so be careful. Anyway, I was at some big dinner of centenary something in Imperial College, and there'd been some heavy rain in 2007. I said, you know, guys, if this is true, there's going to be, because it happened in 1875, it's going to happen again and again and again. And they said, oh, no, come on, shut up, Piers, you know. Anyway, I did make it that point then, and what do you know, in England, there were floods in 2007, in 2008, 2009, corresponding to floods in 1875 and 77. There was not in 2010, not in 78, there was some in the north in 2011 and 1879, and 2012 was the wettest ever for blah, 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 and 1880 was also the wettest ever for blah, 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 in certain parts of the UK. You know, the months might be different and so forth. So not clockwork, but fantastic. And this is what the Met Office had said. They had said we'd have barbecue summers. That's their summer of 2007. That's the one of 2008. And that's the one of 2009. Now, at the end of that, you think they might have said, Mr. Corbyn, do you want to talk to us? No, they didn't say anything like that. They carried on with nonsense and saying it's all man-made climate change. In fact, it's raining, although we expected droughts, it's all climate change. So, it's climate change, it's proven. It's CO2. Okay, pay your taxes now. Right. 60-year cycle, very important in many things. Mississippi floods, for example, but there's loads of stuff that comes and goes in, like a likelihood of occurrence type of stuff in 60-year bursts. And there's a little formula, those who like formulas. It's just beats, it's music. It's music. It's the music of the spheres, if you like. One is the nodal crossings, the other one is the Hale cycle. Okay? And that gives you 58 years, or 59 years. And the average periodicity between North Sea storms in Britain is 58 years, going back to 1216. I mean, give or take years each side, but that is a long time. Not CO2. Now, in detail, how does this 60-year cycle work? Well, don't take these things literally, but this graph, this shows these temperatures, see? Now, if the yellow is an odd cycle, so we've just marked the peak of an odd sunspot cycle to the minimum following. So that is just the maximum and falling stage of the odd sunspot cycle, okay? The blue arrow means that there was a nodal crossing, an eclipse of the sun, which is obviously a nodal crossing, in the first half of December of that year, or of a year. And you mark it if it happens. And that, of course, that's just a measure of saying, well, where is the nodal rotation in that year? And anyway, they're marked here, look. Cycle 23, bingo, they're close together, 21 knot, 19 knot, 17, bingo, there we are, warm, warm, you see? So that is a measure, sort of hiccup in clockwork of when we're going to get these extra warmings. Explicable in astronomical terms, and must be involving electricity just because of the certain things I've said anyway. Now, we know it's important for entertainment, of course, so we move on there. But seriously, though, this stuff is very important. And the problem with CO2 policy is it's pointing the world in the wrong direction. And, you know, I've been to big meetings of the International Association of Operative Millers, North African branch, for example, which was in Tunisia, so it was a good place to go. They're the millers of all the wheat in North Africa and the Middle East. And I've also been to big commodity things, GAFTA in meetings in Geneva, where they want to hear from me about what we're saying about, you know, mini ice age and so forth. And they're just not interested anymore. They're not interested anymore in what the global warmers say. So the support for global warming is disappearing from the people to whom it matters. And we have to be in there. Right, a list of a few things we predicted. This is about 2012, there was really big stuff there, and I remember appearing in What's Up With That website, you might know it. Now, they're lukewarmists, so although they're critical of the big global warmists, they don't like people like me who are realists, where we say CO2 zero effect. So, I mean, I think their approach is batty, but anyway, there we are. So they decided to do an assessment of our July 2012 forecast, because I'd said it's going to be giant hail, searing heat. It was really over-the-top stuff. And they started assessing it, and halfway through, they stopped assessing it. So, no, we can't carry on with this anymore. Because to prove they were right and I was wrong, they had to start arguing about, was this hail giant or large? I said, leave it out. Look, it was big hail, OK? And there's, no, it wasn't big enough. I mean, please, you know. But we're going to get into that. So you've got to be very careful what you say. Just say largish hail, possibly big, you know. OK. Now, 2012 in Britain was a year of no summer. And interesting, there was also one in 1816. And also, and it's run off the page here, I think, there was also a major reduction in sea ice in 1816, as there had been in 2012, just before, in the Arctic sea ice. And this was reported by the Royal Society to the Admiralty. It wasn't the Royal Society telling the Admiralty what to do anymore. If you recall, since 1765, when they're set to with about Harrison, there had been the Battle of Waterloo. The Battle of Trafalgar, which was won by the British, as you well know, which is probably why we're speaking English now. And you see, the Royal Society then, it was probably more like it had become by then an extension of government, you see. Okay. But anyway, they were reporting to the Admiralty and telling them there was not much sea ice. But the point is then, that was a time of the last mini ice age. So what was causing this melting was actually sea currents, nothing to do with atmosphere. It was sea currents. And during these periods of wild jet stream, you also do get more sea currents changing. And some of them will be warm currents whopping into the right place to melt the ice. And that was all that was happening. So the melting now is not evidence of anything other than similarities in the past when we had another mini ice age. Fasting forward, 2013 we predicted that big storm that hit Britain and Europe, and we did actually predict that at a conference, that conference in Geneva, from 6 months ahead, not in so much detail. And near the time we said, we went on about the details, and I'll move fast now. There was a corresponding thing in America, which was big and quite a significant type of configuration, which was spot on, dare I say it myself, but I think Bob Weber would agree. moving these fast. Now, on that big storm, there was some quite significant thing we said, and I'm just going to mention this. We said it's going to turn right compared with standard meteorology from a day or so ahead, and it did. Okay. Now, that's quite complicated stuff, but we said that. Now, the idea that these recent storms are anything to do with man-made climate change is delusional nonsense, and that is put politely. Okay. We predicted all 12 of the storms that hit, all 12 of them. And CO2 predicted nothing. I mean, for them, they said it was going to be a dry and coldish winter. Oh, please, please. Heaven preserve us. Okay, and this Haiyan, this massive thing, this just ramped up in one of our R5 big solar hit periods. Okay, am I going fast enough? There's another example of big hits in America. Whoops. A lot of the early 1800s, pictures by John Constable of similar skies to what we've seen now in Britain, late springs, not this year, but last year, late spring, or the year before rather. And he sold his pictures in, of course this is the Napoleonic Wars, he sold his pictures in France because people in France liked to think of England as being a boring, rainy place. But you know, he was a good recorder. I don't know why they wanted to conquer us, given that, but anyway, there you are. Okay. So we announced the Ice Age, mini Ice Age has begun there. Well, I announced it on my birthday, which I thought was good, because the jet stream was a long way south, so it was a good time. The point is, this stuff is predictable. The solar lunar action technique can do it in essential detail. Now, I want to mention a few things here. Loads of stuff we predicted these things, including this tornado swarm which destroyed Joplin. Now, this is a picture of August the 15th, 2010. This is Jetstream pictures, and Jetstream is suddenly hitting Leningrad, Petrograd, St. Petersburg now, right, that one. And the West Russian heat wave was about to end, and we predicted that's when it would end, and it did. And here, next one, we're going to now see a video of what happened on the sun, which we predicted would happen, or in general terms, there'd be something happening on the sun. And 15 minutes later, we had a big hit in the ionosphere shown by this, okay? So now I'm told if I press this, it'll just come. Ta-da! There we are. Fantastic. This is Ralph. Thanks for fixing this. There we are. Wisdom. Okay, guys, I knew you'd like that. Well, but that stuff was a big one. NASA said it was a big one, and it had the effect we said, including the ending of the rainfall in Pakistan at the same time, or the big rain, because there's one jet stream, all connected world systems. Okay. And it was 15 minutes later that we had that hit on the ionosphere, and then 12 hours after that, the thunderstorms. But the 15 minutes means that some effect was travelling at half the speed of light. I mean, it must be an electromagnetic effect. It could have been particles, of course, but, you know, or a mixture. Interesting. Now, we're getting near the end, Citizen, but we haven't got there yet. December 2010, we predicted it would be the coldest December for 100 years. And when I wrote that down, I thought, have I written that? And I said, yes, okay. And we put it out. People were saying, all my friends were saying, oh, this is a bit over the top, isn't it? Anyway, it did happen. It was the coldest December for 100 years. And in the middle of it, the BBC phoned me up and said, Mr. Corbyn, would you like to come on the breakfast show? You know, sitting round the couch, laid back and talking, wow, you know. I said, great, I would. And they said, okay, we'll arrange a taxi. We'll phone you up later about the taxi. And I said, waited about 2 or 3 hours. There were some friends. What's going on? I think. So I phoned up. Said, oh, "Where's the taxi?" He said, "Oh, Mr. Corbyn, we've decided we were having somebody else. I said, yeah, but hang on, we predicted this stuff. Don't you want to maybe hear from us? No. I said, who are you having? And they said, she didn't want to say. And I said, well, come on, tell me. She said, we're having the government's chief scientific advisor. And I said, he knows FA. And I used the longer form of FA. And I haven't spoken to that channel since. Well, there we are. Truth is not very evident on the BBC. Okay, now I think we've got to speed up. That was the Joplin I mentioned. Oh, this one. I've got to do this one. You okay? He's happy. Okay. Hurricane Irene, we predicted that from 85 days ahead. We predicted something was going to form near the Bahamas and go up the coast of America, east coast, and not hit America. It's going to go close, but not hit. And this is based on an interesting look back. I thought, now, it's pretty skillful. You might say, well, wait a minute, are you sure it's not going to hit? I said, no, it's not going to hit. Anyway, it came on time, and indeed, it did head that way, and Obama's administration was saying, oh, it's going to hit America, come on, bail out. And he was having all these people shunting around. And we said, no, it ain't going to hit, don't worry. And I had a conversation with a guy in NOAA, and he was really interested. I mean, he was genuinely interested. He said, Mr. Corbyn, that's tremendous, you know. And I put out short-range forecasts. They were saying it's going to hit. I said, no, it's not going to hit. And it didn't hit. Okay. And they had these guys on CNN, they were swaying around in the wind in New York, or pretending to sway around, saying, it ain't very windy, is it? You know, it's not very windy. I thought, no, of course it isn't very windy. You know. It was hilarious. Anyway, after that, you were expecting I was going to be phoned by President Obama himself and say, Mr. Corbyn, we need you to help us. But I haven't had the call yet. So I think there's something wrong with your system, okay? Well, you know, it's a sad thing, but science is not being used to the full. All right, that's a bit about New Zealand. Fantastic. I like this picture, isn't it? Isn't that beautiful? That was Newcastle Bridge being hit by a little thunderbolt. Okay, but we'll have more of those, I'm sure, as the mini ice age approaches. We haven't got time to go into that. How much time have I got? Maybe 2 or 3. That means 4, doesn't it? Okay. Right. That was the July 2012, which I told you stories about. Oh, CO2, we'll probably cut this a bit. But just to say, look, if this is serious CO2, let's just have a look at other things that produce CO2. Termites produce 10 times more CO2 than that. 10 times. And it goes up and down. So Obama should declare war on termites. And we should march for that tomorrow. There's no time to be lost. Okay. Now, okay, jokes aside, but let's be clear. The CO2 theory fails not because most of what I say works, it's because it's wrong. It fails itself. Evidence does not match their theory. There we are. They said temperatures would go up when temperatures went down and so on. And without going to much, they had world runaway warming, we've had cooling, droughts in each UK, it was cold, end of snow, good heavens. More US hurricanes, we had less, and so on. It's just all complete nonsense. But what is their answer to this? See, their answer, well, it should be scrap the theory, but no, their answer is we're going to change the facts. So they changed the facts. Here we are. I won't go through the detail, but basically the black one is the data set they were using in 2000, and they've had successive changes. And yes, Minister, this is real data, but they don't say it's different from the real data we used before. And now we've got another one which shows a bigger change, i.e. colder in the past and warmer at present. And the difference, the fiddle factor, the lie, the trickery, the fudge, is 0.5 degrees. So actually, the warming period we've just been through is the same temperatures as in the 1940s or 30s. The same. No change. Now, on the question of what we say about these people, I think we do have to be careful. There are some genuine people in the other side who, do want to do science, and they're just being misled, and they usually come and join us. There's others who are liars, fraudsters, and tricksters, and they should be called that. Okay? Too much there. That's the 800-year lag. We've done that already. That's BBC fiddling the facts on the Arctic sea ice. We needn't do that. Yeah, they changed their nomenclature from climate change, from global warming to climate change because the world wasn't warming. We know that. This is how it does work, in my view. Solar activity, and this, a lot of this, there's loads of stuff I don't understand, which I'm sure Electric Universe is will help understand, and I've got to try and link the two a lot more. But basically, solar activity, magnetosphere, jet stream circulation, and that controls CO2. It's not the other way around. Otherwise, thank you, applaud that, yep. Otherwise, we could blame the US economy upsurge for increases in solar activity. Which, okay, why not? Why not? Yeah, drive that car for a solar flare. Okay, and I think I'm reaching the end. Oh, this is the penultimate slide. Penultimate slide. Okay, this is very important. If you don't remember anything, remember this. This was done by Timo, who's now dead, a climate skeptic, climate realist, whatever. He plotted 220 years separated, or 221 years, averages of solar activity, smoothed out a bit, but we know from the 22-year argument, if it's smoothed out more than 22 years, they're going to, it's a good measure, okay, and it will correspond to weather. So he said, look at this, blah, 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 they move together, and he did this in the past. Now we are here. That's where we are. We're at the knee. We're now going to have more or less a catastrophic drop in world temperatures, which will be more extreme. Some bits will be warmer for short times, even hot, very hot even, but there'll be big extremes and generally cooling until at least 2031 or 2035. That is the mini ice age, and it is here, the beginnings of it now. There'll be lots of things will follow. Some things are going to be more of these sandy type storms, because that Irene, for example, skirted. But Sandy, when it came along, whacked into New York because there was a flux of cold air which came down due to a wavy jet stream, which linked up, complicated, but it linked up and it dragged in that cyclone, hurricane, onto the land. There'll be more sandy type storms because of the wild fluctuations in the jet stream in the next 20 years. That's about the coming 25 years, going to be more of them, general cooling, and a lot of extremes, giant hail, and so forth. And I think that brings us to the end. This is what you've got to do. You've got to enjoy life. Thank you. You've got to enjoy the planet, accept that we can't change climate, but, echoing the point some others have made, there is good things to be done in, biodiversity and so on, but we shouldn't allow these liars and con men to take over doing good things. I mean, for heaven's sake, we should champion honest green policies. We should use science and to make long-range forecasts, and my point 6 is change the world starting now. Thank you.